Thanks, everyone. We've got one more talk before the break, so I'll do my best to hold your attention. Can you hear me okay in the back? Great. Yeah, so I'm Amy Fingerle. I'm a PhD student at UC Berkeley, and today I'm presenting on behalf of a collaborative effort among myself and my advisors at Berkeley, the Karuk Tribe, the Salmon River Restoration Council, Wild Salmon Center, and UC Berkeley. And I'll be sharing the first 2 years of results from our effort to monitor spring run Chinook salmon, or ishyâat in Karuk, across the Salmon and mid-Klamath rivers. It's not news to probably anyone in this room that although this is a moment of tremendous hope and optimism for the Klamath Basin as a whole, it's also a very critical moment for spring Chinook in the Klamath. This map shows the historical and current distribution in the Klamath Basin. Spring Chinook were historically found in the upper basin and tributaries of Upper Klamath Lake. But these areas in the lower basin outlined in blue show the remaining populations of wild spring Chinook. And this habitat is just a remnant of their historical range. So we have wild populations that exist in the Salmon River here, and then in the South Fork of the Trinity River, there are low numbers of spring Chinook remaining. It's not shown on this map, but the New River also is home to wild spring Chinook. But it's really the Salmon River that hosts the last viable population of wild spring Chinook in the basin. And I use that term viable rather liberally, as the Salmon River population is at a critically low size. And in fact, escapement has averaged just over 200 fish in the last 10 years. So in this moment of essentially existential crisis for spring Chinook, I think it's important to take a step back and think about why spring Chinook exist over evolutionary time. Spring Chinook are known as premature migrators or early migrators. They, as adults, return to fresh water from the ocean in a relatively sexually immature state. And they do so early, months before spawning and months before fall Chinook in the same system. There are a lot of disadvantages, very strong disadvantages to this life history. Salmon put on over 99% of their body mass in the ocean. So by returning to fresh water and foregoing growth opportunities in the ocean for some number of months before spawning, they're reducing that potential for growth by occupying far less productive freshwater habitat. And they're also exposed to extremes of flow, temperature, disease, and predation in that freshwater habitat. And these are all issues in both the Klamath and Salmon rivers. But so to exist over this long evolutionary history, there has to be some advantage that offsets those disadvantages. Otherwise, we would see spring Chinook with us here today. And this paradox of their existence of other premature migrators in other life forms of salmonids, this paradox was explored in the 2016 paper by Tom Quinn and his co-authors. And in the abstract of this paper, they hypothesize that this advantage that spring Chinook have, the reason that they enter freshwater early, is that they're making the best of a bad situation because access to suitable breeding sites is constrained seasonally by flow or temperature regimes. So in the context of spring Chinook, this means the ability to access habitat that is not accessible to later migrating fall Chinook. We've thought a lot about spring Chinook over the last 10 years, and our take on this of what advantage spring Chinook have is that early freshwater entry, rather than just making the best of a bad situation, is actually the price of admission to this high quality, near exclusive spawning and rearing habitat. Unfortunately, in the Klamath and the Trinity rivers, and in fact, many systems across the range of spring Chinook, access to this habitat high up in watersheds has been restricted by dam construction and water diversions. In the Salmon River, we have something else going on, and I'll get more to that in just a moment. I want to take a minute, though, to really drive home this point that migration timing by adults can impact habitat access. This hydrograph on the left shows mean discharge near Stones Bar in the main stem of the Klamath River over a 13-year period from 2007 to 2020. And there's a calendar year on the x-axis. And it's shaded to show the upriver migration timing by adult Chinook, shaded for spring Chinook in green and fall Chinook in blue. And what you can see is that spring Chinook are migrating upriver as adults when flows are substantially higher than fall Chinook. A consequence of this is that spring and fall Chinook are encountering features on the landscape, such as waterfalls, boulder cascades, under very different flow conditions. And this results in different passage opportunities. This photo shows a historical waterfall on the south fork of the Salmon River, and this is an example of where you might encounter a different passage opportunity. So you can imagine when fall Chinook hit this barrier, they were perhaps encountering this close to base flow conditions, and maybe it looks just like this. That leak height may have been too great for fall Chinook, for all fall Chinook or many fall Chinook to pass that barrier. Conversely, spring Chinook, they're coming in on snowmelt. That waterfall may have been completely submerged. That leak height may have only been a couple of feet high, and they may have had no problem passing over that. Why this is significant is because we don't have a lot of temporal segregation in spawning between spring and fall Chinook on the Salmon River. And so this box shows peak Chinook spawning timing on the Salmon River. We have peak spring Chinook spawning occurring about 2 weeks, depending on the water year, before fall Chinook. And there's considerable overlap between the times when they're spawning. And so there's not a lot of temporal segregations. This really points to the importance of spatial segregation between these 2 points. We're increasingly concerned about hybridization between spring and fall Chinook, in part because there are just so many more fall Chinook than spring Chinook. So having some mechanism to provide segregation and spawn timing and space is very important. What we know has happened on the Salmon River is that there has been modification by dynamite of at least 4 low flow barriers that historically impacted fall Chinook migration. This is a schematic of the Salmon River from Soames Bar at the mouth upstream to each of the forks near Sawyers Bar and Cecilville. And this shows the places on the river where these modifications occurred in the early 80s. There was 1 location on the main summit, Bloomer Falls, 2 on the South Fork, and 1 in Woolly Creek, which is the largest tributary to the Salmon River and important spring Chinook habitat. These were done in the name of providing fish passage under low flow conditions. And writing at the time, or soon after, the biologist for the Forest Service, Olson and Dick, said most of the natural barriers to anadromous fish migration, consisting of falls and bedrock restrictions, have been modified to provide for passage during low flow conditions. So this was done with good intentions, but we're now understanding that there were unintended consequences of these modifications. And as a result, spring Chinook have largely lost near exclusive access to habitat. I want to point out that although these barrier modifications occurred in the watershed, barrier removal has lowered the threshold for fall Chinook access to upstream habitat, but access may still be difficult in the driest years. And as an example of where this may occur in the mechanism that may still be providing a degree of separation, this is a photo from the lower North Fork of the Salmon River provided by Karuk Tribe. And you can imagine that in a very dry year, this may act, this boulder cascade may act to filter out some fall Chinook. So there are still some places like this on the Salmon River that under dry years may become relevant to this discussion. So we approached this monitoring project in the context of spring Chinook biology and this history of what we know has happened on the Salmon River in mind. So in the Salmon River, we had 3 primary goals. We're looking to evaluate the proportions of Chinook run types within and across Salmon River subbasins and years. So we're looking at the proportions of spring Chinook, fall Chinook, and heterozygotes, which have 1 copy of each run timing gene. We're also looking to monitor the spring allele frequency and determine its distribution. So how common is the spring run genetic variant in the population? And then we're also seeking to evaluate the relative impacts of escapement over summer conditions and fall flows on spring Chinook production. We're also working with partners in the mid-Klamath and increasingly above the historical site of Yreka Dam to determine the presence and distribution of the spring allele. It's of course, a much larger geographic area that we're looking at there, so our goal is a little bit more modest, at least at this point in time. So an overview of how we did this. Beginning in 2023, we collected fin clips from juvenile Chinook throughout the watershed, and we did this in a variety of ways. We operated rotary screw traps at 3 locations in the Salmon River. So there's a screw trap down the main stem of the Salmon River. These are denoted with the purple diamonds. There's 2 there because the trap is moved during the year. And then we have a trap on the lower North Fork of the Salmon River, about a mile up from the forks. And at the Henry Bell site on the South Fork of the Salmon River, we are also operating this screen trap there. Additionally, we're going to where the fish are to complement these stationary passive screw traps. We're going with seine nets where the fish are, conducting grab sampling at over 20 locations throughout the watershed, and primarily targeting the forks to get a better sense of what's going on there in terms of distribution. We're taking advantage now of advances in genomics. We can take a very, very tiny piece of tissue sample and genotype that at a region of the genome that is diagnostic or runtime. As I transition now to discussing our results, I'm going to switch to discussing through years. So we collected samples in 2023 and 2024, but as we're thinking about what is essentially causing production differences between years, we're thinking about the conditions that the adults experience to produce these juveniles. So I'm going to transition to talking about 2022 and 2023. So this table that's about to pop up is a summary of the data for the first 2 years. And there's a lot of numbers here, but I'll walk you through it. And right now I just want you to pay attention to the first 2 lines of this table. These lines show the data that we collected at the lower salmon rotary screw trap. So we've got, we have through years 2022 and 2023, N is the number of samples that we collected. And then the 3 next columns show the number of each genotype that we collected. So in 2022, we found 17 juvenile spring Chinook out of a total of 291 samples, producing there in the parentheses 6% of our catch that year. So 6% of them in 2022 were homozygous spring Chinook, and so on for the heterozygotes and for the homozygous following. The most important numbers that I want you to pay attention to are this spring allele frequency, and there's about to be a reference popping up to highlight that. So this number is very important because it takes into account the 2 copies of the spring gene that are in the homozygous spring run, and salmon are just like us. They have 2 copies of each gene, one from mom, one from dad. The heterozygotes have 1 copy of each of those genes, 1 spring gene, 1 fall gene. So this allele frequency is taken into account the copies that are in the spring run, but also that 1 copy that exists in the heterozygotes. And what we found is that the spring allele frequency in the first year was 3 times higher than the spring allele frequency in the second year. We did a permutation test and found that that was significantly, statistically significant. I'm also here for this presentation pulling in the same data that we have from the North Fork of the Salmon River. We wanted to confirm that sampling biases from the trap didn't affect our results, and also to get a better look at production differences occurring in the basin. Turning again to the spring allele frequency, we find a similar pattern there, and actually even higher ratio of spring allele frequency between the 2 years. Another way of looking at this is to consider just the number of spring Chinook that we caught, so leaving the heterozygotes out, just the pure number of fish. And we see a similar ratio between years with higher spring Chinook genotype production in the first year versus the second. I want to take a moment to look visually at our data from the upper North Fork of the Salmon River, because these data confirm the pattern that we're observing at the main stem rotary screw trap. So this map is repeated twice, once for each year, 2022 on the left, 2023 on the right. And this is a map of the upper North Fork of the Salmon River. So from approximately River Mile 20 near Idlewild Campground down to close to River Mile 7 in the vicinity of Red Bank, for folks who are familiar with that portion of the watershed. Each of these pie charts shows one of our sampling locations that we conducted via seine net, and it shows by color the relative proportions of each genotype found in that location at that year. So we have spring Chinook in blue, fall Chinook in green, and heterozygotes in green, and fall Chinook in yellow. And then the number in the center of each pie chart is that spring allele frequency. What you can see very clearly here is that in the first year, spring Chinook were dominant at many sites. The opposite pattern was true in brood year 2023, where we had fall Chinook dominant, and even far up on the North Fork at Idlewild Campground, we didn't find spring Chinook at that site. So we wanted to get a sense of what was causing this difference in spring Chinook production, and we explored three primary hypotheses. Of course, you can imagine that all three of these come into play, but we're looking at what is the primary driver behind these differences. So the first hypothesis is escapement of both fall and spring Chinook, so the number of adults of each run type that are returning to the Salmon River each year. The second is considering river flow during over-summer folding by adult spring Chinook, because those adults are hanging out in the Salmon River all summer before they spawn just before fall Chinook in the fall. And the third is river flow during fall Chinook spawning migration, with the idea that lower flows during the fall would restrict access by fall Chinook to upstream spring Chinook habitat. So we'll explore each of these in turn. First, looking at escapement. We found similar escapement between years for both spring Chinook and fall Chinook. These numbers were quite similar, so we felt we could move on from that hypothesis. The second is looking at over summer conditions. So this hydrograph is from the period of June 15th through the end of August. We have discharge, first on the y-axis. What we're seeing on this hydrograph is the dashed bold line is the historical median discharge. And then we have 2022 in the blue line and 2023 in the red line. We would predict that better over summer conditions in the form of higher flows would lead to higher spring Chinook production, because those are better conditions for spring Chinook to hold in. Flows may be a proxy for temperature, and it's likely that spring Chinook would have better conditions to support their persistence through those hot summer months. But that's not what we found. We found higher production in that first year when flows were below average throughout the summer. Turning to our third hypothesis, this hydrograph showing a similar thing in terms of 2022 is in blue, 2023 is in red, but now it's showing the period from early September through mid-November. So this is the period of the flows during the fall Chinook spawning migration. We would predict that lower flows during the fall would lead to higher spring Chinook production, because it would reduce the access by fall Chinook to spring Chinook spawning habitat. And indeed, that's what we found. We found higher production in that first year when fall flows were lower. And this points to the importance of barriers in isolating these two forms. So turning back now to this premature migration paradox, our data support the hypothesis that spring Chinook production is primarily driven by the ability of spring Chinook to access habitat that is inaccessible to fall Chinook. And so this provides support for this idea that early freshwater entry is the price of admission to high quality, near exclusive access to spawning and rearing habitat. Before I wrap up, I want to spend a minute to share our results from the mid-Klamath. We conducted sampling at key mid-Klamath tributaries, and we've also been working with the California Department of Fish and Wildlife to collect samples in their screw taps on the Scott and Shasta rivers. Ultimately, we found that the spring allele is rare in the mid-Klamath. Anecdotally, spring Chinook have been reported occasionally in other mid-Klamath tributaries, but in our project, we so far have not detected spring Chinook outside of the Salmon River. We did, however, find heterozygotes in very low abundance, both in the Scott and Shasta River rotary screw taps and as well as in our same net efforts in Independence Creek. This year, we're continuing to sample key tributaries. We're continuing to work with CDFW on the Scott and Shasta, and we're also working with the agency to expand sampling into newly accessible habitat. So to wrap up, I want to point out that what we're finding is that spring Chinook really can't catch a break. At the end of July, when we're getting ready to do the Salmon River dive, I feel this excitement. We feel this excitement when flows are looking good, when temperatures are good, great conditions for spring Chinook. But we're finding actually that these better over summer conditions may correlate with upstream access for fall Chinook. And these data point to management actions in the Salmon River. They suggest that these management actions could limit fall Chinook access to upstream habitat, and this will be key to increasing abundance both on the Salmon River and promoting repopulation of the upper Klamath Basin. The reality is that with climate change and reduced snowpack, spring Chinook may not have a long-term future in the Klamath River. It's really heartbreaking to think about and to say out loud, but that's what the data by many others show with how conditions are changing. The best hope for spring Chinook is in the upper basin. They have great habitat up there, but we need a healthy Salmon River population to provide those wild genetics and help get those fish up there to the Klamath tribes. One management action that we are pursuing is the installation of a low flow weir. This would be operated during base flow conditions after spring Chinook are already in the system. It would provide a degree of habitat exclusivity to spring Chinook by restricting fall Chinook access to a portion of historical spring run Chinook habitat. Weirs have been used in traditional fisheries management in the Klamath and throughout the range of Chinook since time immemorial. They're, of course, in use for other purposes throughout the basin and other places in California and beyond. And a weir, it's not the end game. It's not something that would be operated from now indefinitely, but it's a stepping stone to help hold on to this spring Chinook population in the Salmon River while that upper basin population is getting established and giving the Salmon River a chance to contribute to that recovery with those wild genetics. So happy to talk more about that with folks anytime. There's a lot of people who've contributed to this project, both in the field. There's a tremendous fieldwork component to this. Those names are listed here. There's also a lot of people who've gone into making this work possible in other ways. And we've had to pull from many pots of money to make this work possible. So many folks to thank for making this work happen. My email is listed here in case we don't get a chance to connect today, but in the meantime, I'm happy to take any questions. Thank you.
Seems like these fish need the spring Chinook being really deep holes to summer in. How are the holes doing on the salmon? Especially with all the fires.
Yeah, so there may be other folks who can speak to kind of more real-time conditions. I know that the South Fork, and we've seen this actually in our data, has suffered with the debris flows that occurred in 2022 and early 2023. Were filled in holes. I think some of them. So they are still there in some places, certainly relative to the historical conditions of where mining, we're in a highly degraded state in that regard, but remnants of that habitat are still there. Yeah.
Did you look at water temperatures during the migration time and during the adult holding time?
No, but that's something that I would like to do, as we get closer to preparing a manuscript. Right now, we're sort of using flows as a proxy for temperature, but we do have temperature data, and knowing that Chinook are continuing to both flows and temperature, it would be great to incorporate both of those flows and see how well they correlate, and how also pulling in spawning data to think about migration triggers and how far upstream fish are migrating.
On your out migrant and your seining efforts, what is your window, like the earliest you're sampling there? And then when you get in to start that sampling, are your fish big enough to sample, or do you have to wait?
Yeah, that's a good question. So each year, so we're now in our third year of our project, and each year we've been able to get out earlier. And I think the seining this year started in February. I think last year it started in March. The first year we were waiting on permits, so it's slightly later, maybe May. We were out there. They are generally off the bat able to be for us to take fin clips. We can start at 30 millimeters. So they're right there at that size, and we can sample them. I think occasionally we'll see something smaller, but for the most part, we can take samples right away. Yeah.
With the installation of the low flow weir, does that look okay and realistic from a permitting standpoint? Does it seem to have the support of the agencies? And then would it be something that's temporary and you assess the genetics and other factors to see, how long, make sure it works before you just continue it forever?
Yeah, permitting was has been one of my biggest hesitations with this product, but actually, we have a good relationship with the agency. There's a lot of permits that go into this work already. And it's actually looking to be not the holdup that I thought it was. We've gotten very good response from the agencies, including the Forest Service that we've started to have conversations with. So I think, especially on the federal side, it's like, are the people going to be there to process the permits? Which is not something that I would have anticipated being an issue, but so far so good with that. And then in terms of, kind of, the idea, we're still working out the details, but the idea is to have a weir and adaptively manage it, and to use a really nimble and flexible structure so that we can make changes on the fly as we're learning more. We've got great monitoring infrastructure in place from this project, so the timing is really advantageous in that sense that we can, right away. I mean, we have a 3-day turnaround time in terms of getting genetics results, so we can know and quickly like what we are seeing and make changes within the season or from season to season as necessary.
Quick follow-up. What locations, because you mentioned the 4 historic places, would it be all 4 spots or just trying initially at 1 or 2?
No, so, we know that these barrier modifications have occurred in specific locations. My approach to it is less that we're trying to recreate a specific barrier, but more that we're trying to restore a process that these barriers provided. We haven't yet settled on an exact location, but right now, so the mid-South Fork is kind of rising up to the top. It could change year to year, but that's the discussion we're having now. Yeah, morning.
Hey, Amy, you mentioned significant overlap temporally between the spring and the fall fish within the basin. How much spatial overlap have you been able to document or identify?
Yeah, so something that I haven't presented here, but I have been genotyping the adult carcass samples that are collected during spawning surveys dating back to 2017. And we're finding, fall Chinook in Cecilville. We're finding heterozygotes up near Idlewild, and then we're finding spring Chinook at the end of October down near Forks. So there's a lot of overlap that's happening. Of course, most of the spring Chinook we're finding up high. Most of the fall Chinook we're finding down low, but especially mid Forks, there's a lot going on and a lot of field calls that we're now learning weren't always correct. Sarah,
do your heterozygous fish end up following the fall behavior pattern?
Yeah, so what we know about hets is that they tend to enter freshwater from the ocean closer to spring Chinook, but then once they get up to the spawning grounds, they tend to be kind of like ahead of the fall Chinook run. And the genotype data from the carcasses seem to support as well, but we haven't done a formal analysis of that yet. Okay.
Getting kind of to that, if you're constructing a low flow barrier weir, would it be something that in certain water years would allow passage? Because presumably throughout like the historic record, there would have been years where fall run fish could get up really high. And if those heads are kind of following the spring run entry timing, it just seems like those heads could be important to the long-term persistence of both spring and fall.
Yeah, so we still have so many details to work out regarding the weir, but I think the idea, as I see it, as we see it, is that it would not be something that's going to be in there to withstand these very high flow conditions. So when it would have occurred historically that you get this pulse and flows, this freshet in the fall and fall Chinook are moving up, we're pulling that weir out, for example. So it's trying to mimic that historical process that has just been overcome.
Laurel's online.
Oh, yeah. Laurel, go ahead.
Yeah, I just wanted to confirm it's not really anything about habitat limitation. It's really just isolating the genetics. Is that what this is all getting at? Because these numbers are so low, I'm assuming there's plenty of spawning habitat up high still.
Yes and no. The historical condition of the Salmon River may have been such that there was ample spawning habitat, but so much of the Salmon River, especially the upper forks, because of mining and other land use impacts, has remained in this degraded state where there's just not great spawning habitat in a lot of places. So I mean, when I was at SRC, we kept trying to get funding to do a spawning habitat assessment. That's a question we don't know that still should be answered. But we do see red superimposition. There may be some of that more direct competition that's happening on the spawning grounds. And so that is a concern, as well as hybridization. Yeah.
How much do we know about the natural barriers, and could you sort of use those to inform the management practice of a low flow weir or?
Yeah, so we don't know as much as we would like to know is kind of the short answer. There is some information in Forest Service documents. There's some, ability that, a hydrologist doing a PhD could spend a few years like reconstructing these barriers and pulling together different sources of data to do that work. But we're using the genotype data as a proxy to show that these barriers aren't functioning, and being able to look over time, kind of correlating when and where these pulses of flow are occurring in the Salmon River and how that might be affecting fall Chinook migration would be a way to think about, what is the CFS threshold at which having a barrier there, wouldn't be historically relevant. Yeah, Raymond.
Looking outside the Salmon River Basin, it seems like we're in a crux moment for the potential for restoration of spring Chinook in the Klamath River Basin as a whole. And I'm wondering how much thought is going into, the possibility in this moment when spring Chinook could theoretically have exclusive access again to habitat and above other lake, but may or may not, depending on, alteration of historical low flow barriers on the mid-Klamath that might allow fall Chinook to be getting higher than they used to, or, conditions in upper Klamath Lake, whether, we don't know yet, whether fall Chinook will be able to migrate through upper Klamath Lake. It just seems like there's this moment when there's a lot of potential, but also a lot of uncertainty in what might happen in the upper Klamath. And it seems, if people care about the future of spring Chinook in the Klamath Basin, like we're really keen on them to be thinking those thoughts, not just in relation to the salmon, but in relation to what goes on in the dam and local reach.
Yeah, absolutely. That's well said. I agree.
I know this may be more of a question for CDFW, but in terms of harvest management, I think Chinook have been traditionally managed fall Chinook. And I'm wondering if, imprint data like what you're capturing or in other science, are there any shifts towards also trying to manage for spring Chinook from a harvest perspective? I don't know, maybe that's Crystal or Morgan.
Well, I mean, I can just say, loosely, at least with respect to the in-river fishery, prior to the listing spring run, the fishery in the lower river opened well before the onset of spring run, and while the spring run fishery in river has been closed for the last likely 3 seasons, 2 for certain, that fishery since the listing hasn't opened until July 1st, trying to provide a protection for early running homozygous spring run fish.
If there's some out of Mike Belcheck has the question. Go ahead, Mike.
Yeah, the issue of spring Chinook harvest is always on the Karuk Tribe Council's mind. This year, the tribe closed its fishery except for 1 day a week. There was a lot of vigorous debate in the tribal community about this. This is the least days per week. Well, I think we've had 2 for a while, but this was prompted by the concern for wild springers right now, and I believe the data shows that the harvest rate on remaining wild springers, which is a great concern to the Karuk tribe, is very low at this point.
Thanks, Mike.
And Mike Orcutt has a question. Go ahead, Mike.
Well, first one would be how much this is driven by the petition for listing, because we, at least as far as my understanding, it's been petitioned in 18 and they're still sitting on the determination yet, so I guess generically, how much of this is driven by any of that requirements, information, data, but I would also note that I believe it was for fall Chinook a number of years ago. It seems like to me, the numbers that we're talking about, I look at it a couple hundred to 1,500 in the Salmon River Basin for spring run. That there's a thought about a viable population, and I know they done an analysis on fall run in the past, and it was like 720. So you might be well below the threshold of that. And then on the management side of it, I would just put some insight into that. We've explored this for a long time with the Klamath Fish Management Council, but where that sits presently, at least on the Pacific Council, as far as ocean fishery management, there's a placeholder for Klamath Trinity Spring Run, but there has yet been an analysis to develop what's called conservation standards, like there are for fall Chinook. And so it's largely like other fisheries, bycatch and other fisheries, that spring run is it's not actively, at least in the ocean fisheries. And as well in the river fisheries, I think the state has taken some action, and I also believe they're listed. Anyway, everybody knows all that information. So, but I would also say the same statement that Mike Belchek said. We've also done the analysis because there's this concern about South Fork spring run Chinook. The harvest rates based upon the hatchery populations are really low anyway, and so the point there is harvest is not going to get you where you need to go, and so but it all kind of is in the realm of the listing and what NOAA makes whenever they make their final determination. Thank you.
Yeah, thanks, Mike. I appreciate your comment, and I'll just say, I don't actually know the present status of the federal listing petition, but this work is, would hopefully feed into any information requested by the agency, but is being conducted independently of any policy decision.
All right, thanks, Amy.